हेलो क्लास। हम प्रीवियस क्लास में देख चुके हैं टॉर्क ट्रांसमिटेड बाय सॉलिड शाफ्ट। सो इन दिस लेक्चर वी सी टॉर्क ट्रांसमिटेड बाय hollow shaft. सो hollow shaft, ठीक है। तो फर्स्ट देयर इज अ hollow shaft, internal radius r, outer radius ro, and we consider an element ring thickness dr, and T is torque transmitted by the shaft, and tau is maximum shear stress induced at outer surface of the shaft, and small q is shear stress induced at the elementary ring. Now from the torsion equation we seen in previous lecture, tau by r equals to q by r. Okay, tau is maximum shear stress induced at the outer surface, and here is distance from the center equals to shear stress at the elementary ring divided by distance from the center. So small q is equals to tau by r is r naught. There is radius, outer radius dot radius of elementary ring. Now the turning force F equals to shear stress into area q into dA. We know the dA is r, small r, dr. This is dr, small r, dr. Oh, sorry, this is small q is tau by r naught dot r, dA is same dA. Now we put dA value which is 2 pi r dr. So 2 pi here, tau r naught r outer dot r into r is r square dr. Now the turning moment is turning force into distance of the ring from the center. So there is turning force, here is turning force into radius r. So it will give 2 pi tau by r naught, r outer is r outer, radius of outer shaft dot r dr. Okay. Now the turning moment from inner radius to outer radius, here is total turning moment dt is turning moment on the ring. So here is dt. So we will put here integrating this term are constant because it will integrate with respect to small r. So our integration of r cube is r to the power 4 by 4, limit r inner to r outer. So we will put the limit of upper limit minus lower limit. Here is upper limit minus lower limit. This equation is for total turning moment. Now we know the diameter is 2 times of radius. So we put in terms of diameter, so it will give 5 by 16 tau d outer to the power 4 minus d inner to the power 4 divided by d outer. Okay, this expression for torque transmitted by the hollow shaft. Now next one is power transmitted by the shaft. So what power transmitted? So it will determine here is n, that means rotation per minute of the shaft. N is rotation per minute. T is the torque transmitted in Newton meter, and omega is angular speed of the shaft. So power transmitted by the shaft is torque transmitted into angular speed. So it will give omega equals to 2 pi n by 60 into T. There is expression for power T. Power T. Now it's time to push numerical problems. So here is a problem. Two shafts of the same material and of same length are subjected to the same torque. If the first shaft is of a solid circular section and second shaft is hollow circular section, second one is hollow circular section whose internal diameter is 2 by third of the outside diameter, the outer diameter, and the maximum shear stress developed each shaft is the same compared weight of the shaft. In this question, material is same, length is same, and torque is also same, and the shear stress developed in the shaft is also same. Now we compare the shaft. For this question, here is we know here is material is same, that means density of the material, weight density of the material is same, so we know the weight density is weight of the solid and weight of the solid into volume. Now the weight of the volume is pi by 4 d square into n, or for the hollow, for the density of hollow circular section is density of material, weight density of material into the volume, so it will give weight of the hollow circular section. So here we first calculate volume, so it will give pi by 4 d square into L for the solid circular shaft, and pi by 4 d outer square minus the inner square into L. So length is same, material is same, that means density is same, so we conclude relation between diameter of hollow hollow shaft and solid shaft. So first let torque T transmitted by each shaft, because torque is same, shear stress developed in each shaft, which is also same. D is diameter of solid shaft, D outer diameter of hollow shaft, D inner. Ws represent weight of solid shaft, Wh weight of hollow shaft, L is length of each shaft, gamma is weight density of material of each shaft. Now torque transmitted by solid shaft is T equals to pi by 16 pi d cube. This is we seen in previous lecture and previous derivation. So T equals to pi by 16 tau d cube. For hollow, T equals to pi by 16 tau d outer to the power 4 minus d inner to the power 4 by d outer. Here we finding here this term. So from the question, d inner is 2 by third times of d outer. So put it here, and here it's power 4. So 2 to the power 4 is 16 and 3 to the power 4 is 81. Simplify this, so it will give 65 by 81. Yes, 65 by 81. The outer cut, it will give d cube, d naught cube. Now torque transmitted is same, so equating both the equations first and second. Here is first equation and second equation. It will give the relation between diameter of solid shaft to the outer diameter of hollow shaft, where d equals to 0.929, the outer, and in this question the inner is already in terms of the outer. So we conclude the weight. Now weight of solid shaft is density of solid shaft into volume of solid shaft, density weight density gamma s into pi by 4 d square L. This is the volume of the solid shaft, and the hollow shaft gamma h, that means weight density of hollow shaft into pi by 4 d outer square minus d inner square into L. We know the d inner in terms of d outer. We put the d inner value, and it will give weight of hollow shaft. Okay, which is gamma h into pi by 4, gamma h into pi by 4 into 5 by 9. Here we weight 2 by square of 2 by 3, so 2 square is 4 and 3 square is 9. Here we add, here is subtract from 1, so it will give 5 by 9. Okay, now dividing fourth equation by fifth equation. Now Ws by Wh, material is same, so W in gamma s and gamma h is equal. Now pi by 4 and LLL is same, length of both the shaft is same. Now equating. Now we know the D in terms of D outer, which is 0.929 D outer, so it will give 1.55 here. The ratio between solid shaft to the hollow shaft, weight of solid shaft to the weight of hollow shaft is 1.55. Okay. Answer. Now next question is, find the maximum shear stress induced in a solid circular shaft of diameter 15 centimeter when the shaft transmits 150 kilowatt power at 180 rpm. Here is rotation n is given, diameter of the solid shaft is given, and the power is given. Now we know the power in terms of torque, so we find out first torque. So P equals to 2 pi nt by 60. This is seen in the previous derivation. Here this is power transmitted by the shaft. So which is, we use this equation in finding out the torque transmitted by the shaft. Here we finding out, we put the values of all terms. So power is 150 kilowatt. So in terms of watt, kilo is 10 to the power 3. And n is 180 rotation per minute divided by 60 into t. So we finding out t from here. So torque is 7957.7 Newton meter. Okay. Now from the torque we know the torque transmitted in terms of shear, maximum shear stress for the shaft, is T equals to pi by 16 tau D cube. So we finding out tau from here. T is 7957.7 into 10 to the power 3 because D in mm. So we convert it Newton mm, and pi by 16 tau D is 150 mm. So we put it here. It gives, and the shear stress is calculated, and now it will give 12 Newton per mm square. This is the answer of this question. Okay. Thank you.